సార్ లైన్ లో
స్టార్ట్ చేయొచ్చా?
సార్ తీస్తాను ఫోన్ ఇప్పుడు.
గుడ్ మార్నింగ్ సార్. సార్ గుడ్ మార్నింగ్ సార్.
గుడ్ మార్నింగ్ సార్.
స్టార్ట్ అయిందా ఇప్పుడు?
స్టార్ట్ ఓకే సార్, ఇప్పుడే స్టార్ట్ చేస్తున్నాం సార్, మీరు జాయిన్ కాగానే సార్.
హలో
సార్, గుడ్ మార్నింగ్ వన్ అండ్ ఆల్.
గుడ్ మార్నింగ్ సార్.
Myself, Dr. M. Manjanelu, in choice of national webinar on role of remote sensing in geosciences. Welcome you all. First of all, my sincere thanks to Honorable Vice Chancellor, Professor C.H. Gopal Reddy sir, and respected Registrar, Professor T. Krishna Rao sir, for accepting my request to conduct one-day national webinar on role of remote sensing in geosciences. It is my pleasure to invite Honorable Vice Chancellor, Professor C.H. Gopal Reddy sir. Professor C.H. Gopal Reddy sir hail from Karimnagar district, Telangana state. He did his BSc from Kakatiya University, Warangal in 1981, MSc Physics Solid States specialization from Usmania University, Hyderabad in 1983. He qualified NET JRF in 1984 and he has been working as a faculty member in the Department of Physics, Usmania University since 1990. He has two research projects, one under DST PURSC program of Usmania University and another research project funded by Atomic Energy Regulatory Board. One more research project funded by UGC DAE Consortium for Scientific Research ongoing. In addition to, he was co-principal investigator in two research projects funded by Department of Science and Technology and AERB. 5 research students were awarded PhD under his supervision and 4 more are working for PhD degree. More than 55 research papers has published by in several international and national journals. He has attended several national and international conferences, seminars and workshops. He has life member of Indian Science Congress Association, Luminous Science Society of India, Indian Society of Radiation Physics, Nuclear Tracks Society of India, and Indian Association of Physics Teachers and Society of Advancement of Solid State Sciences. Earlier, he has worked as in charge head Department of Physics at Usmania University PG College, Nalgonda, and academic coordinator and vice principal at University College of Science, Saifabad, Hyderabad, and he had head Department of Physics and chairman board of studies in engineering physics at University College of Engineering, Autonomous Usmania University, and joint director and director at Directorate of Admissions, Usmania University. He has successfully served as the registrar, Usmania University, from November 2016 to May 2021. During which time the celebration of century of Usmania University. Welcome to you, sir. It is my gratitude to invite Professor T. Krishna Rao, respected Registrar of MG University, Nalgonda. He was born in Hyderabad, Telangana State, India. He has received his master's degree in philosophy and MPhil and also doctorate degree from Usmania University. He started his career in Department of Philosophy, Usmania University. He lectured in 1992, promoted as associate professor in 2002, and become a professor in 2009 and continued to hold this position. He worked as a convener for proposed All India Vice Chancellor Conference of the prestigious OU Century Celebrations and convener for Vice Chancellor Conference OU Century Celebration and Association of Indian Universities. He is serving as a Dean Faculty of Arts and Social Services, Palamuru University, Mahbubnagar. He served as a professor, Head Department of Philosophy, Chairperson, Board of Studies, Philosophy, University College of Arts and Social Sciences, Usmania University, and is member of various boards of committees of the university. He has over 30 years of teaching, research, and administrative experience. He has published many research papers in various international, national journals and conferences. He guided many PhD scholars in the field of Western and Indian philosophy. Among them, 4 scholars were awarded PhD degree and 6 research scholars were submitted their thesis. Welcome you, sir. Now I invite the chairperson of the webinar, Dr. G. Upendra Reddy Garu, for encouraging the every moment of the webinar. Welcome you, sir. Now I inviting the guest speakers, Senior Scientist Sri Mallesh Ganji and Sri Anup VM, Geological Survey of India Training Institute, Hyderabad. Welcome you, sir. This is my time to give a brief on the webinar. Today, webinar, role of remote sensing in geosciences. The remote sensing is a science and technology acquiring an information without any physical contact. The remote sensing, an important tool in mapping large remote area and many applications. So by using the remote sensing, we can do the analysis, the natural hazards. We can create the geomorphological maps, mineralogical maps, hydrocarbon explorations, etc. I hope this webinar may give many clues to the students and research scholars. Thank you. Now I request today guest speaker, Senior Scientist Mallesh Ganji, give a brief on the seminar.
Thank you. Thank you, Dr. Manjanailu, Head of the Department, Geology, Mahatma Gandhi University. I thank Vice Chancellor and Registrar and University College Principal for giving this opportunity to interact with the people of Mahatma Gandhi University on the occasion of one-day national webinar on role of remote sensing in geosciences. So nowadays, remote sensing role is going on increasing, not only in geosciences. Every science is interconnected with the remote sensing, because we have already explored the surface areas, surface deposits, and where we can approach and we can explore the mineral deposits. But the unapproachable areas, especially forest areas, hilly areas, we cannot explore directly. So this remote sensing technology is very much useful to explore mineral deposits, not only mineral deposits, the life or the anything which is available in the unapproachable areas, we can detect with this remote sensing techniques. So without wasting much time, I am giving to Dr. M. Anjaneyulu for further. Thank you.
Thank you, sir, for giving good message. Now I request to guest speaker, Senior Scientist Anup sir, VM, give a message to the students and scholars.
Thank you very much, Dr. M. Anjaneyulu sir, Head in Charge Department of Geology, MG University, Nalgonda. I also thank respected Honorable Vice Chancellor, MG University, Nalgonda, and all other organizing committee who has invited us for delivering a lecture session on role of remote sensing in geosciences. So as a remote sensing, as a tool, it will always enhance a geologist and a person who is working as a geoscientist to explore many things which we can directly in contact. So apart from that, a geoscientist or a student who is learning a geology, this tool will definitely help them to gain a job in the market. If you remember, these days, geospatial technology is gaining a lot of importance in our day-to-day life and in various applications. So once they learn about this particular technique, and if you are there having a particular hands-on training on these kind of subjects, it will be a great advantage for each and every students who are passing out from a geology background. So by keeping this in mind, I once again thank all the organizing committee of this one day webinar for inviting us. Thank you so much. Thank you very much.
Thank you, sir, for your message. Now I request respected Registrar Sir, Professor T. Krishna Rao, address the meeting.
Sir, Lademo, I think he's not there in the
Sir.
meeting now.
Sir. Okay,
Sir, Lademo, sir.
Sir will join, I think. Sir, now I invite to the Chief Patron, Honorable Vice Chancellor, C.H. Gopal Reddy, sir, address the gathering.
Thank you, Dr. Anjaneyulu. So, Krishna sir is not the registrar anyway. And two guest speakers, today's scientists, Sri V.M. Anup Garu and Sri G. Mallesh Garu, Principal, University College of Science, Dr. G. Upendra Reddy Garu, Dr. M. Anjaneyulu, Head in Charge, Department of Geology, University College of Science, Mahatma Gandhi University, and other distinguished participants from across the country. I'm very happy that our university, the Department of Geology is conducting this one-day national webinar on the role of remote sensing in geosciences. Of course, briefly, the two guest speakers and this remote sensing techniques and what are its uses. I've been working in Usman University earlier, and there we have the Department of Geology, Department of Geography. Department of Geology is mostly doing work on these remote sensing areas, and Hyderabad is famous for the institutes related to geosciences. For example, NRSA, National Remote Sensing Agency is there, GSA is there, and other very big institutes are there. For example, even NGRI, I think they are also doing some work on this area. It's an important actually technique, as the speaker said, to know several things, the forest coverage, the morphological mineral mapping kind of thing. So in several areas this technique is being used, and even we have tried to use this technique in our Usman University also. Actually, we wanted to see what is the Usman University now and what was the Usman University, let us say, from about 10 years back. The forest coverage, the number of dwellings that have come up in the university area, because it's a big area, around 1,600 acres of area is there, and several illegal encroachments are taking place. And we wanted to know what was Usman University about 10 years back, because we have these pictures were there actually, the satellite images were there. And now also we have tried to do something. Srinivas Reddy, I think you must be knowing, he was our batchmate. Using his help, we have taken such measures actually. It's an important area, and several years are there. And I'm sure that this one-day webinar will give more insights into this particular technique, particularly to the young generation, to the research scholars, to the students, and those who are interested in this area. I congratulate our
Thank you, sir, for valuable suggestion.
Anji, wait.
Yeah, thank you very much, sir.
Okay, Anji, now continue.
Sir, Thank you, sir, for spending your valuable time. Now I request.
Thank you. Anil, I'm leaving this meeting because I have some other meeting is there now. So
Okay,
I'm
sir.
going there.
Okay, sir. Thank you, sir.
very much.
Thank you, sir.
Okay, sir.
All the best.
Thank you, sir. Thank you, sir. Thank you. Sir.
Right.
Sudha.
Anji, start the section.
Yeah, distinguished guests, dignitaries, staff, students, and my dear participants, a warm and graceful morning to one and all. I would like to thank our Honorable Chief Guest, Professor C.H. Gopal Reddy, Vice Chancellor of Mahatma Gandhi University. And I would like to thank our guest of honor, Professor Krishna Rao T, Registrar of Mahatma Gandhi University. And also I would like to thank today's chairman of this event, Dr. G. Upendra Reddy, Principal, University College of Science. And I would like to thank the convener of this event, Dr. M. Anjaneyulu, in charge at Department of Geology, and organizing committee, and who are participating and making this event in a grand way and fruitful way. And the session will be start. Thank you one and all once again for being part of this event.
Now, I am Dr. Madhusudan Reddy, Faculty Department of Geology. I will introduce about the Anup VM sir. Sir has been a senior geologist in PGR division, GSAT, Hyderabad. Now he is completed his MSc Geology from College of Engineering in Anna University, Chennai. Is a professional experience, particularly associated with the RMSI Private Limited as a GIS engineer in Agriculture and Natural Resources Division during 2008 to 2011. He is the most field experience, particularly in the field of geology. He has carried out various mineral exploration projects, particularly hyperspectral, multispectral remote sensing studies. It includes like gold exploration, particularly in northern Sudan, and also he has been worked in different chromite blacks in Turkey and India also. Sir also most experienced in the paleochannel studies for diamond exploration in South Africa, and he also field experience, particularly in this geophysical data in the field of seismic, particularly in island exploration in Yemen and Peru countries. And also, sir will be more experienced in the geological mapping, in the compilation of geological data based using Landsat imagery, satellite imagery in North Korea. Now, sir, as a joined in 2011 in the UPSC, and initially first he had joined in GSI in Bihar in 2012 to 2017, and as promoted in 2016 as a senior geologist, And in GSI, Hyderabad GSI TA, he joined in 2017. And sir has published about the different publications in GSI and other CGWB about particularly some of the publications in high rare earth elements concentration in Rajnar and Parman and the Nevada district parts, and also geological study of low discharge of Saraswati Nala in and around Rajgir town, Nalanda district in Bihar, and also potentials of hyperspectral radiometry for iron ore grades. And also we have seen about the cartography, those indices, the mineralization in flow of height. Particularly, this is about the some biodata about the Anup's VMSA. Next. Now, I welcome to Anup's VMSR. The session will be start, sir.
Thank you so much, sir, for the very detailed explanation about my profile. And what I can say, once again, a very warm good morning to each and every participants and dignitaries who are there. So myself, Anup VM, senior geologist from Geological Survey of India Training Institute. So my voice is clear, I hope. And let me share the PPT. Then we will start our session on remote sensing and its application in geoscience. So let me just share the screen. 1 second, please. So I hope my PPT is visible to you. Can anybody give
Yes, sir, it is visible.
Thank you. So we will start our session now. So if you have any doubts, you can put it in the chat box later on after completing the session. I will try to answer to those things. I hope that will be the best way to interact. So without much delay, I once again welcome you all to this particular session. So this is about the principles of remote sensing and its applications in geosciences. As a part of one-day national webinar conducting by the Geology Department of MG University Nalgonda, we are here to discuss about these concepts of remote sensing. So for the students, I'm just taking the audience mostly as our student community. Most of you may be learning this particular subject, remote sensing, in your academics. You will be having one paper in remote sensing. So these days we are using the remote sensing in our day-to-day life in many ways. If you book, particularly if order any food, if you order any cab, or if you are calling a cab and all, a cab fellow or a food delivery boy, he will be reaching to your doorstep by not knowing your name or not knowing your any other details, only by seeing the location. He will be having a map in his mobile. You might be shared your location in that one, right? So that location he will be searching and he is reaching to your doorstep, into your apartment or into your house. So this is what normally these days it is very famous. Zomato, Swiggy, all these things, right? Even in the small towns also we are having this kind of facilities. So how they are seeing this map and what way these maps are prepared. Okay. I request other participants to mute yourself, otherwise it will be a disturbance to the others who will be listening. So please mute yourself, then it will be fine, I guess. Okay. So that map, day-to-day map is updated, right? So earlier days, the survey and all these things take in after 5 years or 10 years or like that time period. But nowadays, our life become very faster. We require more applications and all. So all are depending upon these our handheld devices. So these maps, how they are updating today. Just now, our respected Vice Chancellor sir was saying they are in a project to understand about the changes happened in the Osmania University campus, right? 10 years before, how Osmania University campus was there, and now how it is. What are the changes happened? So if you give this job, we cannot go to the past. So what will be the information? How you will collect those information from satellite imagery of 10 years back or 20 years of back, we will be analyzing. So like that, the changes, whatever happening on our Earth surface, that is easily mapped using this remote sensing imagery. As you are seeing this screen on the your screen, you can see from our space how our Earth looks. This is only a part I have given for the simple understanding how a imagery look. Those who haven't seen an imagery. So here you can see our country, India, nearby countries, Bangladesh, Pakistan, Sri Lanka, and further Arabian countries you can see. So when you analyze a particular imagery, from that many informations we can take. That may be about the land, water body, buildings, many things, right? So to updating the maps and all these days, these kind of imageries are in use. So how it is done? So for that, we are using this remote sensing technique. So all of you are studying this particular technique. So always remember, especially for the students and research scholars, I am mentioning this. When you are learning a theoretical part, try to involve what are the uses of this particular science or this technology. Then it will be more interesting for us to learn those things. Okay, so now I am taking you to the definition or what exactly this particular remote sensing, this particular science, how it works and what it mean by. So all those things we will be discussing now. So you might have learned in your academics what is remote sensing. So many things are happening on our Earth surface, many processes are happening, many changes are happening, many features are there on our Earth surface. So directly if you are going to the field, you can observe that one. Otherwise, suppose by sitting here in this particular place, if I want to know the changes which is happening or what are the things which are happening on the Earth surface in for the time being, we can take the example of Russia and Ukraine. You might be seen in the few days before in the newspaper and all, how their war front is moving on Earth surface. One satellite imagery was there. So such kind of movements we can observe. And if any disaster, any natural disaster occur, that change we can occur. If any changes happened on your campus for the last few days before, if a satellite has passed around that area, that might have taken the imagery. If you analyze that incident, you will be able to pick up. So using remote sensing, we can acquire, we can process and interpret the satellite imagery or related data which are acquired by the aircraft or satellites without direct contact on the Earth's surface. So there are different number of satellites are moving around our Earth surface. They are taking the information about the Earth surface information, different processes which are happening, all those information they are collecting. And this information in the form of an image we are analyzing. So this way remote sensing works. So it is a collection of information about an object without being in direct physical contact with the object. So this is the theoretical definition you may be required when you write an exam or any other you may be required this kind of a definition. But more than that, if you try to know about this particular subject, you should know more about the applications, how this remote sensing is. Okay. So I will try to play one video over here, so you will be able to know about what exactly this one looks like. So just see here, I'm just trying to switch in a video over here. You can see our Earth surface. we are moving away from our Earth's surface. This is entire globe. You can see there are many satellites which are moving around our Earth, right? You can see they are acquiring certain information from the Earth's surface. It is not one satellite. There are many satellites are there which are having different applications. 1 second, please. Okay, so sorry in between interruption. So you can see that it is continuously taking the information, and the satellite there will be sending the signals. Okay, so that signals will be received by the receiving stations, right? And that information we can analyze for our various studies. So this way our remote sensing works. So you can see here in this pictorial representation, so there is a source of sunlight energy will be there, right? Sunlight energy falls on our Earth surface and it will be reflecting back. Then that particular energy that will be captured or recorded by the sensors which are there in the satellite. And these satellite, they will be sending these signals further. You can see into the receiving stations will be there. They will receive those signals and process the data. These data we will be working for various applications. So if you want to understand about the different processes involved in a remote sensing, you can see there will be a source of illumination, that is our sunlight. There will be a interaction of this particular energy when this energy is falling on the Earth surface. It will be interacting with the atmosphere. Certain processes will be there, and there will be an interaction of this energy on the object on our Earth surface. Some of the energy it will be absorbed, some of the energy it will be reflected back. This energy which is reflected back, that will be recorded by the sensors in the satellite, and they will be sending the signals. We will be having different receiving stations on our Earth surface. In Hyderabad, we are having in Shadnagar, NRSC, they are operating, they are having a receiving stations. So there these signals, they will be acquired. From there the signals will be converted into the analog into the digital forms, and we will be getting the satellite imagery processed data we will be getting. So as a geologist, my application will be there to use these data for our geological interpretations. A person who is a geographer who is working, he will use that for an urban planning or any other environmental related studies, such kind of things. So each and every one of us in the scientific community, we will be having different applications. We will be using this satellite imagery. So the entire remote sensing, that process, it involves all these things, whatever I have told you. Energy source, then radiation, their interaction in the atmosphere and interaction in the on the surface with the target object. Then this recording energy by the sensor which are mounted in the on the satellites or aircraft. Okay, then they transmit this energy from one form, electronic form, to a digital form, and we interpret this data for our various analysis.
Excuse me, sir.
Yeah, please.
Yeah, slides are not changing, sir.
1 second. Currently, are you able to see that energy source of illumination A, B, C like that?
No. Only first slide it is running, sir.
Okay, 1 second, please.
Make it a PowerPoint presentation, sir.
Okay. 1 second. Is it visible now?
Screen not shared, sir. Till now.
Let me share.
Not visible, sir.
Yeah. 1 second. Let me share again. Is it showing now?
Yes, sir, it's showing.
Okay. So now the screen, it is a thank you for informing. If anything, such any technical problem is there, please let me know. Thank you. So now you can see that energy a source of illumination. There are different elements involved in remote sensing that you can see here. That will be an A, B, C like that we have marked over there, right? So what I was explaining, sunlight energy that will be interacting with the atmosphere. Then you can see it is here you can see it is interacting here, it will be interacting with the atmosphere, it will be falling on the surface, it will be interacting with the target, it will be reflected back. This energy will be recorded by the sensor which is there in the satellites. Then it will be sending as a signal into the receiving stations. Then further for the various applications we are getting the as an imagery. So this is the entire process which is involved in our remote sensing technique. After this, once the data we are receiving, we will be processing those datas and all, right? So that we will see in further, right? So this is the explanation for what I have discussed already. So I'm not repeating it again. Whatever you have seen there is ABCD, like energy source of illumination, radiation and atmosphere. That energy which is traveling from its source to the target, it will interact in the atmosphere. That we will discuss again further in our coming slides. Then interaction with the target. That means when the energy falls on the surface, there are different objects on the surface. It will interact. It will do certain reactions and based on the object property, material property, that is there. Then recording of energy by the sensor, that is there, right? So after finally for different applications we are using this particular satellite imagery. So up to this we were discussing in the previously. So further coming to the next slide, I hope the slide is visible to you. Evolution of remote sensing. So if you heard about remote sensing, most of you might be heard it is related with the satellite imagery and all. If you go about 30 years back or 40 years back, it started with aerial photograph. Or 50 years back or 60 years back, if you take in the initial time of remote sensing, it started with a balloon survey. A person who will be sitting in a balloon, where big balloons and all, hot balloons and all. He will be taking a camera. He will be capturing the information about the city or town and all. And those pictures, photographs were used. Later on, aircraft, they used to fly above the surface carrying a camera. So aerial photographs started to use for our various application. Later on, satellites arrived. Different satellites we started to launch. These satellites, rocket satellites, they will be carrying certain sensor. Yes.
Sir, I request sir, Anup sir, again slide is not changing, sir. Once you check this.
Okay, 1 second, please. I don't know what is happening. 1 second, please. Let me. I will try to off my camera and all sometimes.
Okay, sir.
Is the screen is visible now?
Yes, sir.
Yes, sir. It is visible.
Okay. Let me run in this mode. Actually, I don't know when we are putting the screen share. If any issue is there, I will try to run in this mode. I'm trying to put it in maximum. Let's see if any issues comes or not. I will try to share in this manner. I hope it is visible to you all. The screen you are able to see.
Yes, sir.
It is readable, no? You can read the things, right?
Okay, yes, sir. It's visible.
Okay. So let me try to scroll like this, and I don't know if again the problem comes. We'll see. Okay. So different evolution of remote sensing we can see like this. So there are different changes from the balloon to the aircraft, then to the spacecraft, then to the drones. So nowadays we are using the drone techniques and all. We are using different drone imageries for analyzing, for understanding the features and all. So these are the changes what happened in the remote sensing. So from an aerial photographs where the aerial photos were used to analyze, then the multispectral satellite imageries have come up, then further hyperspectral data with more number of bands and more information we started getting. That is advantage of hyperspectral imageries. So we will be able to analyze the in particular material, their spectral responses we will be able to differentiate when we are having hyperspectral data. Then further the platform, the thing is the drone data. So here few things you have to understand. One is about the sensor. The changes happened in the sensors from a camera to the panchromatic sensors to the multispectral sensor to hyperspectral sensor. Now we are into the hyperspectral stage with the sensor. Same time, the particular platforms which are taking this particular sensor, like from the balloon to the aircraft to the spacecraft, now into the drone. So in both this area, these changes have happened in remote sensing, basically. So as an aircraft, the platform wise also the things have changed. The sensor, its quality, the technology have changed, and we are having the better sensors to analyze the information from our Earth surface. So in both these things, the change in remote sensing, we can say change in the remote sensing technology, we can see from the last 30 to 40, 50 years, we can say. So if you take, I think the slide has changed now. You can see the system overview in remote sensing.
Yes, sir.
Okay. So if you take the entire remote sensing, it consists of platform, sensors, product, and processing part. So platform, what I was mentioning just before, it may be a balloon, it may be an aircraft, it may be a satellite which we have launched, or it may be a drone, or it may be a spectroradiometer. So different platforms are there for carrying out remote sensing studies. And talking about sensor, the sensor which are mounted on these particular platforms, they are basically two kinds. We can say passive sensor and active sensor. We will discuss it all in detail in the coming slide. Then about the products, different type of products. From our aerial photograph to satellite imagery and drone imagery, different type of imageries we are getting. That is there. Then about the processing part, it consists of digital image processing. We are using various softwares to process this data. Okay, so that is the entire remote sensing, we can say. Now we will discuss in detail about the remote sensing platforms. So as I told you, we are having different type of platforms, the way we are taking this particular imagery. So that may be spaceborne. If a satellite that will be carrying these sensors mounted, they will be moving around our Earth surface and they will be collecting the information. So that is spaceborne. We are having airborne. So earlier days balloon, then kite, PG, and then aircraft. They will be taking this particular sensor and they will be moving around our Earth. So that is airborne. Then drones we are having. That is also part of airborne. Then third one we are having ground-based. You can see a person who is holding a spectroradiometer. That device is called a spectroradiometer. So it is also having a sensor. So you can take it into the field and you can get those information from the exposures, rock exposures, or any other material exposures. So in all these ways, we are collecting the information. So that particular medium which carry the sensors, we call it as a platform. So in your academics, definitely you will be having in your chapters, what is a platform, what are the different type of platforms and all. So you got an idea, like it is different medium the sensors they will be carrying as a spaceborne, airborne, or ground-based. Okay. So one component we have completed. Next is sensor. Now we will try to understand about the different type of sensors. So here you can see there are different type of sensors are there, right? You can see like a passive sensor, active sensor, like that. So here you can see that in passive sensor and active sensor, on what basis we are saying. I hope the screen is visible to you.
Yes, sir, we can visual.
Okay. So the basic difference we can see in passive and active sensor is about the energy source. In passive sensors, we are having the sunlight as an energy source. The sunlight will be falling, the rays will be falling on our Earth's surface. It will be reflected back. That will be that particular will be energy will be recorded by the sensors which are there in this particular satellites. So that is the case of passive sensors. Normally, we are having multispectral sensors and hyperspectral sensors in this kind of passive sensors. In active sensors, you can see there won't be any external sunlight, natural light source. That means sunlight energy has no role in that one. From where they get the energy, from where they are giving, that particular sensor itself will be sending a signal to the surface. It will be reflected back, and certain kind of backscattering or the time taken by that particular signal to reach the surface and return back, that will be measured. So such kind of a sensor we called as active sensor. Active means they are active themselves. Okay, that sensor, they are active themselves. They are sending the signal. They will be falling on the surface and it will be coming back. It is not as same as what we are analyzing or recording in our passive sensors. Here they will be measuring that time taken by that to return back. All those things are measured. So normally we are having lidar sensor, radar sensors and all in active sensor type. So this is again another type of question probably you will be having in a particular topic you may be having, what are called as sensors and different type of sensors and how they are different from each other. So active sensors, the advantage of active sensor is that if there is a cloud cover on our Earth surface and all we are having, the passive sensors we will not be able to record the information of Earth surface because it will be disturbed with the presence of cloud and all those things. We will be optical energy, it will not come recorded. But active sensors, those signals that can be, they are penetrating, they can penetrate through the clouds and all. They can be used for the collection of information from the surface. So normally that is the basic difference between an active sensor and a passive sensors in remote sensing. Okay. So here again, whatever I have told you that I am just showing you here, a passive sensor, they measure the energy that is naturally available. Sunlight energy will be there that you can see. So such kind of a sensor, they can operate in the daytime in the presence of sunlight, right? Here in active sensor, they provide their own energy. That is what I have told you in the previous slide. So it is about their explanation to that one. Okay. So anytime, regardless of season, regardless of day or night, these particular active sensors, they will be able to record the information from the surface. Okay. So we discussed about platform and sensors. The third thing is about the orbit. All of you are aware that, and I told you in the beginning, there are different number of satellites are there which are moving around our Earth, right? So I hope the orbit, that screen is visible to you, and they follow. I am not putting the animation here because I am afraid that the screen again, if it will lose or not, that is the reason. If you see, I was supposed to run this particular satellite. It is having an animation. It will be moving around this particular path. So orbit is the path which will be followed by the satellite in a space. That is the definition for orbit. That means every satellite, they will be having their own orbit when they are launching. So after we launch the satellite and all, it cannot move as per their requirement. It is already designed by the engineers and scientists who are there in ISRO or any NASA and all, who are launching these satellites. Its path, its orbit is defined before launching a satellite. It will move only along that particular path. Why? Why it is moving along only that path? Otherwise, one satellite, it may collide with the other. Okay, there are many movies you might be seen. English movies, they used to show that the debris which are coming after the breaking of one satellite, it will be hitting on the space stations and all such things. So every satellite, they will be moving around the Earth on a particular orbit. Okay, and the time taken by a satellite to complete one circle around the Earth, we call them as a orbital period also. And there is one more thing you can see on the screen. There is a red line I have drawn, that is called the ground trace. That means when a satellite is viewing our Earth surface, it is capturing the certain information of our Earth surface that will be aligned in a particular way, right? So that information from the ground, which is capturing by the satellite, we call them as a ground trace. Tracing, that term is familiar to all the students, I think. Tracing some map, tracing some image or picture, photo, like that. So it is tracing the information about our Earth ground surface. Okay, so that is about the orbit. Now, this is a very important topic for the students, those who are learning MSc or BSc. I don't think in MSc definitely they will be having, I think, in the your academic the orbit, right? So this orbit, further what more you can add into this orbit? So this orbit, we used to say we can differentiate based on many things. The first thing is based on the altitude which they are flying. So every satellite which are moving around our Earth, they will be fixed in a particular position and it will be moving around our Earth surface. So we are categorizing based in what height we have fixed them to move. So based on that, we are having low Earth orbit, LEO, or medium Earth orbit, that is MEO. Then geosynchronous orbit we are having, and geostationary equatorial orbit we are having. So they are differentiated based on the elevation, on the height in which they are supposed to move or they have designed. So low Earth orbit satellites, normally our Earth observation satellites, they will be moving around the Earth surface around about 300 to 2000 kilometers. That is their particular range. And the GPS satellites, you will be knowing GPS. So these GPS satellites, they are moving around our Earth surface. So global positioning system, GPS, this is also a separate topic you may be having in your academics. As I told you in the beginning, if you are ordering a food and all, we are sharing our location. So based on this GPS location, ground positioning, our location, ground positioning, global positioning system, the technology, the location which we are sharing, so they are connected. The lat-long information we are getting using this GPS and all. Nowadays in every mobile we are having the inbuilt GPS and all, right? So there are different set of satellites will be working for this particular global GPS functioning. They will be MEO, that is medium Earth orbit. So they are in an altitude of 8,000 to 12,000 kilometers away. Okay. Then we are having the weather satellites, which are giving the information about the weather forecasting. So they are geosynchronous satellites. So like this, based on the altitude, we are having different satellites. Based on the inclination they are moving, the way they will be moving. I'll just show with the picture. I'm not running this animation over here. The satellite, this will be moving in a particular axis. So based on the inclination of that, we can say there are different type of orbit. We are having inclined orbit, polar, then we are having different type of inclinations they are maintaining. So based on that, we are having this geosynchronous, polar, geostationary, this kind of movement of satellite will be there. So you can see here a geosynchronous and a geostationary. There is an inclination for the geosynchronous satellite movement, their orbit. Okay. Then polar satellite movement, they will be moving from north to south or south to north. So based on the altitude, based on the inclination and their movement, these orbits are differ, or they are given different names. So if it is moving from north to south, the satellite movement, that is from here, you can see from here to here, we call it a descending path. If it is moving from south to north, we call them as an ascending path. So these are the things you can mention when you are asked to write about orbit. Okay, based on altitude, based on inclination, based on their movement, you can differentiate them. Okay. The another terminology you have to know about is about the swath. You can see the swath width of the particular satellite. When they are moving, they will maintaining a particular width, that coverage, their ground trace, they will be having a particular width of coverage. We call them as swath. Okay, the area imaged on the surface, we call them as swath. Then another terminology associated with this path and row, as I told you, the satellite, they will be moving on a particular path. So later on, once you are about to download a data or an acquire a data, you have to purchase them, or you have to acquire, download them pathwise or scene-wise. So for that, they have designed in such a way, there will be a particular path along which the satellite has moved. They covered the ground surface. Based on that, a path and row index will be prepared for every satellite data. So based on that also we can acquire the data. So that is indicating by a certain number, path and row number will be there for every satellite imagery product. Okay. So since I'm not sharing the screen, I am unable to run this particular animation, because as of now I think our screen sharing is going intact. There is no problem. This animation was supposed to show you the debris population on our space from 1961 to present. So we are having different satellites we are having. So they are moving. Some of them are not in functioning way, but they are moving around. They are there in the space. So scientists are now trying to understand about the traffic jam in the space. Okay. So there are so many satellites are there which are not functioning, decommissioned, and there are many materials, debris are there in the space. So all those things were supposed to show in that one. Okay. Anyhow. So I hope as of now you are having you got an idea about the very fundamental aspects of or the components of remote sensing, right? So I hope the screen is visible about electromagnetic radiation. Is the screen is visible?
Yes, sir. It is visible.
Thank you. Now we are trying to understand about the little bit physics about the this particular principles of remote sensing. In remote sensing, as we have seen, the signals what we are receiving, sending, all those are involved in there. So basically, it's a part of physics. We can say electromagnetic radiation in school days we have learned. So what is an electromagnetic radiation? It is a form of energy transported through the space in the form of a periodic disturbances of electric as well as magnetic field. Okay. So they are moving in the form of a waves, and this wave is characterized by two things, frequency and wavelength. So this particular wavelength information, it is very important to understand in our remote sensing studies. Okay. Why it is, we will come to know in the coming slides. So here you can see the propagation of electric and magnetic field, the wavelength and frequency that you can see over here. So the longer the wavelength, the gap you can see, the longer the wavelength, their frequency will be less. If we can see the shorter the wavelength, their frequency will be more. So that is a relation actually. Okay. So why it is important in remote sensing? That we will discuss in the coming slide. So what is a wavelength? Wavelength is the length of one wave cycle which can be measured as the distance between successive wave crest. In the previous slide, in this slide, you can see this crest. So we measure this distance between these two successive waves. So this is called as the wavelength we are mentioning. Okay. So wavelength is usually represented by nanometer, meter, micrometer in different forms. So a person who is working in remote sensing, he should know a particular data when it is coming to you, in what particular wavelength their bands are represented. This information you should have whenever you are working with remote sensing. Okay. So as I told you, shorter the wavelength, higher the frequency, longer the wavelength, lower the frequency. So that is the relation between the wavelength and frequency. So now I am taking you into the electromagnetic radiation. So we are having an electromagnetic radiation. We are having different wavelength representing ranges in that. Okay. This is the electromagnetic spectral range you can see from a shorter wavelength to the longer wavelength we are having here. Okay. So the electromagnetic spectrum ranges from a shorter wavelength from here, shorter wavelength to the longer wavelength. So it include our gamma ray, X-ray, microwave, broadcast, radio wave, all these things are there. So we are using certain area in this particular wavelength region we are using for our remote sensing studies. So that is the importance. That is why we are trying to understand about an electromagnetic spectrum. So I am just focusing on those aspects only. We all are using this particular electromagnetic spectra or electromagnetic waves in remote sensing in particular wavelength region. So it may be from our optical remote sensing or a passive remote sensing, which cover the visible and infrared range of wavelength. So if you take the electromagnetic spectrum, the wavelength which are representing in the visible range, they are from 0.4 to 0.7. That is our blue, green and red wavelength region. So they comes under visible spectra. And in non-visible spectra, we are having a near infrared, mid infrared and thermal infrared range. So in remote sensing, you have to understand that the satellite imagery what we are working, they are consisting of different number of bands. Each of these band, they will be representing certain wavelength region. Okay. So this is important whenever you are working with our remote sensing. And further you can see the microwaves are there in the longer wavelength region. We are having the microwaves and all. So this wavelength region we are trying to understand, we are trying to know about in the remote sensing. So here you can see the visible range which we can see over here, visible range which we are understanding about in the remote sensing, that you can see over here. So as I told you, there are number of bands are there. Each of these band, they will be representing certain wavelength region. It may consist of visible region, near infrared region. So different satellite imagery, different number of bands will be there. Each band, they will be representing a wavelength region. So that is important in our remote sensing when we are doing the practical aspects of remote sensing. Okay. So this you should remember always whenever you are working. Okay. So this I am not repeating again. We are having different ranges, infrared range, visible range, microwave range, all these things. Next important thing for you, that is about the interaction with atmosphere. 1 second. Okay, sorry. So now we will discuss about interaction with atmosphere. This is important for you, and especially those who are in academics. As we were discussing in the beginning, we can say the primary source of energy is sunlight. When it interacts with the molecule and particle present in the atmosphere, some of these particle, due to this particle, our electromagnetic radiation, that is scattered or reflected or absorbed, right? And some of the energy, some portion of the energy that will be passes through the atmosphere and will reach onto the surface. So here we are trying to understand about the mechanisms which are happening in with the atmosphere as well as on the surface object. So remote sensing will be possible only in certain areas in our electromagnetic spectral wavelength if you take. So some of those energy that will be absorbed by the molecules which are present in the atmosphere. Some of them will be get scattered also. So there comes the term called scattering. So definitely it will be a question to you, what is scattering, define scattering, all those things. So when an electromagnetic radiation passes through the atmosphere, it interacts with the suspended particles such as aerosol, cloud, and other molecules and all. So because of this reason, the scattering process happens. So it occurs when particle of or larger gas molecule present in the atmosphere interact with and causes the electromagnetic radiation to be redirected from its original path. So based on the different materials, their size, we are having different scatterings: Rayleigh scattering, Mie scattering, non-selective scattering, etc. So these are some of the scattering terminology or the scattering ways which are there, right? So this will be important for you in your academics. What is Rayleigh scattering? So it occurs when a particle are very small compared to the wavelength of the radiation. So if you are having a particle in the atmosphere which are very small, that causes this Rayleigh scattering. So Rayleigh scattering is primarily caused by oxygen and nitrogen molecule in the atmosphere. This causes shorter wavelength of energy to be scattered much more than the longer wavelength. So that is the reason we can see the scattering is prominent, right? And it is prominent in the upper atmosphere, you can see. And if you look for the reason why our sky is looking like blue, what time the sky will be looking like blue? In the daytime, because of this phenomenon, because it will be scattered, the shorter wavelength. So in our visible range, we are having the wavelength from blue to red. So they got scattered. So in sunset, we are seeing the red color because the longer wavelength, red color, the reason for that one. Okay. So this way we can say different ranges of scattering effects we can see with respect to the material. Then Mie scattering, it occurs when the particles are of equal to or larger than the wavelength of the radiation. That may be due to dust, pollen, smoke, and water vapor, which may cause this particular scattering. So the cloud, it may appear due to the white color. It is saying that it is due to the Mie scattering. So this way you can say there are different types of scattering because of the particles present in the atmosphere. And another one, we are having non-selective scattering. It occurs when the particles are much larger than the wavelength of the radiation. So water droplets and large dust particles can cause this type of scattering. So all wavelengths are scattered about equally. We can say all these particles are scattered equally in our atmosphere. Okay. This type of scattering causes fog and cloud to appear white to our eyes. And we can see it is because in the equal quantities of blue, green, and red light that is scattered. So these are the different type of scattering. And what is scattering? I hope it is clear to all of you. So definitely these all are there in you will be having, I guess, in your academics to learn. Then comes the absorption. One absorption we have seen about the mechanism of the absorption which is happening in the atmosphere when they interact. Similarly, there are areas in the electromagnetic spectrum that are absorbed by atmospheric gases such as water vapor, carbon dioxide, and ozone are known as absorption bands. Okay, so that is about the absorption which is happening on the atmosphere when they are interacting with the atmosphere. And another term which is very important, that is atmospheric windows. So as of now, you have understood in the entire electromagnetic spectrum, we cannot do the remote sensing. Why? You have seen the absorption of the rays by different molecules which are present in the atmosphere. There are areas of spectrum which are not severely influenced by the atmospheric absorption, which are useful to the remote sensing sensors, are called as atmospheric windows. So just like a window in our room, you can see when it is opened, some air or light will come. Like that, other things, it will be blocked. Similarly, those areas which are not influenced by the atmospheric absorption to the remote sensing sensors, we call them as an atmospheric windows. Then you can see here, when an energy falls on the surface, it will be reflected. Earlier we have seen when they are interacting with the atmosphere, what was the term? Scattering. When it is hitting on the surface, certain absorption will be there on the surface. Then the reflection, which is important. So there are two types of reflections which we analyze. One is specular reflection, another one is diffuse reflection. Specular reflection, when a surface is smooth or mirror-like surface, all energy is directed away from the surface in a single direction. We call them as a specular reflection. Diffuse reflection occurs when a surface is rough and energy is reflected almost uniformly in all directions. So on the natural ground, you will be getting which kind of a reflection? Specular or diffuse. Normally, we will get a in between these two, or we can say moreover it is a diffuse reflection, because our natural surface, it will be not be like a tiled surface. There may be certain areas also. So moreover, it will be in between. So every object on our Earth's surface, they will have a particular spectral behavior. Okay. So when a light falls on a water, its reflectance will be different. When a light falls on a leaf, its reflectance will be different. So every object on our Earth's surface, their spectral behavior, their spectral reflectance, that will be varying. So that will be help us in remote sensing to differentiate different material on the Earth's surface. So we may be in identifying the object on our Earth's surface. Apart from that, if we want to differentiate the material on the Earth's surface, especially in geology, we have to know about the spectral response of each and every object on our Earth's surface or different minerals on our Earth's surface, and that will be advantageous for us. Okay, so that is about the spectral behavior in a nutshell. So I am not going much detail into these things, because as an what we can say, very basically which is required right in the academics, I am just sharing you. So there are different objects on our Earth surfaces are there. Their spectral responses you can see over here. Here you can see the spectral response of different type of vegetations. Here the spectral responses of different materials on our Earth surface, that is given. So the spectral signature or the spectral curve, that will be generated when you are working or when you are analyzing the spectral response. So I think this much is clear to you all. Now we are entering to the next part. So that is like we can say we need to about the resolution. I hope the screen is visible to you.
Yes.
The resolution. So basically we are having spatial resolution, spectral resolution, temporal resolution, and radiometric resolution. So the spatial resolution, that helps to identify the object of a smallest possible size on the Earth's surface. That means if you want to identify an object from a remote sensing data, we need a high spatial resolution data. If you require to differentiate an object on our Earth's surface based on their spectral response, then we require a very good spectral resolution for the data. If we are looking for the changes which are happening on Earth's surface in a consecutive days, a satellite should cover the same area in the very shorter time period. So such kind of a resolution we call as a temporal resolution. And fourth one, we are having radiometric resolution. That is the energy, based on the energy differences, the temperature analysis and all, we use the radiometric resolution. So these are the four different type of resolutions. This resolution is very, very important when you are working on any different projects. Based on the requirement, you have to acquire or procure the remote sensing data. So by giving this much of glimpses, now we will try to understand what are the advantages of remote sensing. Okay, so it allows a broad regional coverage. It allows a continuous acquisition of data. That means a large storage of data will be there. And it is a cost-effective study. if you are assigning a survey, it will take time, it includes much cost. But a remote sensing survey, that will be cost effective also. And you will be getting an archive of data of past many years that you can compare. So with all these things, we are having different advantages in the remote sensing. We are having different advantages in remote sensing. Okay, so basically we use different datas in different purposes, like for multispectral, hyperspectral, thermal remote sensing, microwave remote sensing. Each of them will be having their own specific usages in our geoscience. So for our geological mapping and all, our spectral mineral identification, alteration mapping and all, we use the multispectral remote sensing data and hyperspectral remote sensing data. If you are looking for a thermal differences or a thermal resource and all, we have to use the thermal bands in the remote sensing data. If you are looking for a deformation and all such kind of information, we may have to work on microwave remote sensing data. So each of these particular data and their usage in our different projects, that will be varying. Okay, so there are two types of interpretation or the product which we use for our analysis. One is our pictorial data interpretation, another one is digital data interpretation. So in pictorial data interpretation, we try to identify the objects on the surface from a hard copy imagery or a printed map and printed satellite imagery and all. In a digital image processing, we use running different softwares to get the information from the imagery. So in these two ways you can use, one is pictorial, another one is a digital data. So digital data, they came to exist now in very, there are different softwares are there which you can process those data. So now coming to the data, we should know from where we can get the data. There are different sites are there from which you can download the data. Okay, there are different sites like Earth Data, Bhuvan, NRSC, Bhunidhi site, USGS Earth Explorer. From these you can freely, whichever data which are freely available, you can download those data. So in our Indian context, we are having our Indian remote sensing data, IRS data. We are having a lot many datas we are having, like Cartosat, List 3, List 4, ABIBS. These are some of the Indian remote sensing data product. And our Indian remote sensing data product, we are having a very good or very high spatial resolution data as we are having. And if you see 0.28 meter spatial resolution, that means you will be able to demarcate an object on the Earth's surface which is having less than 1 meter in dimension. See, that is advantages of our Indian remote sensing data. So, and apart from that, medium resolution and coarser resolution, List 3, List 4, ABIBS, these data are also available in our NRSC, Indian with NRSC. You can use it, utilize it for various projects and all, right? So that is about Indian remote sensing. Now we are discussing about different type of globally available data. So there is another data set called as Landsat data. Landsat 1 to 9. Now very recently they started distributing the Landsat 9 imagery also. So for the last, it is available from 1972 onwards, they are acquiring the data. So way back from 1978 onwards in the portal, you will be able to identify, you can download this data. So I again quoting our today's inaugural session, as our respected sir was saying about mapping the canvas. So 40 years back, how was that canvas? We can understand from this kind of data, right? How it is looking now, the present data you can analyze. So there are different type of imageries are available. High resolution imagery, if we take more information of the ground features, we will be able to identify. These all are a little bit medium resolution data, 30 meter resolution data and all. Like you can see here, Landsat 7, Landsat 8. So they are about 30 meter resolution data. Constraints will be there. If you are marking a building and all, it will not be possible because these are a medium resolution. For that, we may have to look for a very, very high resolution data. Normally, they are of purchasing. And there are data which are giving the groundwater information, grace. Such kind of products are also available in our scientific community. So that helps us to predict about the groundwater movement and all. So now we are moving into the application part of remote sensing, geoscience. That is, we are focusing. Apart from that, meteorological, forestry, agriculture, mining, extraplanetary studies, multidisciplinary services like a disaster, defense, coastal protection, hydrology related, all these sectors we are using the remote sensing. Nowadays, it is highly depending upon these remote sensing studies and all. Okay, so taking into the geological applications, what are the applications of this remote sensing? Lithological mapping, mineral exploration, structural mapping, surficial deposit or bedrock mapping, geohazard mapping and planetary mapping, sand and gravel exploitation, environmental geology, hydrocarbon exploration, geobotanical studies. It's lot of events of mapping programs we can plan using a remote sensing data. So here the utilization of remote sensing in mineral exploration, we can identify the structure, we can do the alteration mapping, geomorphological mapping, many things we can do. Here you can see on the screen, we can update the lithology or geology map using the satellite imagery. So visual interpretation as well as spectral enhancements we can do on the satellite imagery. So that is very much useful in our lithological mapping. Then structural mapping, you can see different fault, lineament, fracture, joints, all those things you can easily identify, demarcate using a remote sensing data for a vast area. So that is about the structural mapping. It is also having an important role in our mineral as well as hydrocarbon explorations. So as well as in the hazards also. So we can demarcate using them. Another one application is alteration zone mapping to identify different minerals which are present, mineral indicators, alterations we can identify using the satellite imagery. And geomorphological mapping, you can map different features, depositional, eroded features, super enrichment features, different landform features we can identify using the satellite imagery. Here you can see some of the Mesa, Butte, residual hill, structural bridges, pediment, channel, paleo channel, placer deposit, river channels. All those things you can identify very much from a imagery. Then geobotanical gates, that is there. We can understand about some species of plants which are there. Their spectral behavior we can analyze, which will be helping in identifying the mineral exploration. Then coal fire environment, temperature we can measure. Surface temperature measurements we can take. Then landslide studies, disasters. You can see before and after image. This is before landslide occurring. This is after landslide occurring. You can see the instability studies and all you can do. So how it is affecting the community in this area. All those things we can understand from the imagery. Then tectonic studies, ground deformation studies. So all these are coming under our geosciences, different branches of geoscience studies. We are using different type of satellite imageries, different products. These are microwave remote sensing data. This is a microwave remote sensing data. It is not an optical remote sensing, it is a active remote sensing data. So ground deformations we will be able to demarcate after an earthquake and all. Right? Volcanic eruption. You can see very recently we have seen the volcanic eruptions and all, right? So these are some of the events in different islands which volcanic eruptions have happened. And this is the very latest imagery you can see in nearby Tonga, the island. You might have heard in the news and social media. After a volcanic eruption, one small island, some island name I don't exactly remember, in nearby Tonga, and it generated a tsunami. You can see the tsunami wave which is generated over here in the top. And this is the situation before the tsunami hitting the shoreline in Tongo. This is after the imagery. You can see it causes so many damage, water inundated to the surface, means the shore. So these are some of the applications we can say using the remote sensing in the disaster management. So these kind of studies are the satellite imageries are used in the disaster mitigations and all. So we have seen from our lithological mapping, structural mapping, geomorphological mapping, mineral exploration, alteration mapping. Now it is about the disaster, different type of disasters we can identify from. Then in defense purposes, we are using remote sensing and to measure, to monitor the oil spillages we are using. Then illegal mining activities, mining activity monitoring, that is possible. You can see the Amazon forest. So these are some of the mining activity, gold mining activity they monitored. So that is possible using the satellite imagery. So these are the various applications where this is not the, I'm just focusing on few of the things. Apart from this, for the extraplanetary, the presence of water in the moon, on the surface of moon, and different minerals which are there on the Mars surface. Now using the remote sensing, we have captured the imageries of moon, Mars and all. Now we are doing the exploration activities on the moon surface. If you might have read a few months back, samples were collected from the moon surface, Mars surface, and it is being analyzed. So there are different applications are there. The initiation starting from the remote sensing. So these are the things which I shared for you with you in the last 1 hour. Some technical issues were there. I couldn't show you few of the things in a better way. But still I hope it is clear to all of you whatever we discussed about the fundamental aspects of remote sensing, like electromagnetic radiation, electromagnetic wavelength, what is remote sensing, different orbit platform sensors, type of sensor like active and passive sensor, spectral behavior of material, and interaction of the electromagnetic radiation in the atmosphere, scattering effect, then the reflection effects and all. Then in detail, little practical aspect, resolution of the data, right? Then about the different applications and different products of remote sensing, right? So you keep, this is an interactive session. So apart from this GSI TA, we are conducting lot many training programs. So in the coming future also, those who are research scholars, faculty members and all, you can come down to GSI and you can gain the practical experiences about the remote sensing and all. So these are some of the softwares, some open source softwares you can use as a students and researchers. And these are some of the books you can refer for knowing more about the remote sensing in geology by Ravi Gupta sir. Then if you want to know about remote sensing in GIS, there are international books and national books are there available. You can refer those things. Okay, so by this I am concluding, okay, my session in session. Now you can interact. If any doubts are there, you can interact, right? So by this presentation part, I am just concluding. So if anything to be discussed, you are free feel to ask. There is no other issues. Okay. Don't feel that if you ask a question, somebody else what they think. Okay. Each and every question will be very important for yourself and many other, more than 70 participants are there, 72 or 70 participants are there. So one of your question may be useful for many. So if you are having any doubt, if anything to be discussed further, please. So participants, if any doubts, anybody, any students, if you are having any doubts.
Students, Devendra, Moses, Riyaj.
Any questions from the students?
My name is Devendra, sir. Geology Secretary, Mahatma Gandhi University. Thank you for great opportunity. I have one doubt, sir. What are the similarities between the satellite GIS and GPS and remote sensing?
Okay. There are different types of satellites are there that we discuss for different purposes. Okay. So for the normal Earth observatory, satellites will be there, which will be taking the imagery of our Earth surface or the different changes which are there happening on our Earth surface. So normally you have seen that low Earth orbit satellites. Then there are satellites which will be functioning for or collecting the information for the GPS, global positioning system. For that there are certain satellites which are placed. So they are placed in a certain altitude and all. Their function will be different from the Earth observatory satellite. Then another one, we are having weather satellites. So they will continuously monitoring one part of our Earth, the weather patterns of that cloud movements and all. Mostly geostationary satellites will be there. Then another in the question what I felt, GIS, that is our geographical information system. So that is an application where we take that GIS, it is having different way of application, taking the base of satellite imagery or any other informations. We can create different maps or different thematic layers regarding our flood studies, landslide studies, many things we can say. Okay, so there we use the GIS application, geographical information system. For that one we are using. So that is about the satellites and different type of similarity or the differences we can say. Then there is a query. I hope it is clear to the participant who had asked the question. One query is there regarding the spatial and spectral resolution. Okay, I will explain about that one. Spatial resolution, as I told you, suppose it is the ability of the sensor to demarcate or to identify a smallest possible object on our Earth surface. That is by definition. Suppose on our Earth surface, when a satellite sensor it is watching, it is acquiring the data. Suppose we are having a town, a small town area. There are so many buildings will be there. There will be vehicles will be parked over there. Many things will be there. Suppose that the sensor will be designed in such a way 1 meter into 1 meter. That means 1 pixel of that particular satellite imagery, that is of 1 meter into 1 meter. It will be having an ability to identify an object on our Earth surface of that dimension. Sometimes the sensor which we will be having, that particular sensor, it will be having a 30 meter into 30 meter spatial resolution. So it will not cover that small object on our Earth surface. It will be showing you when road will be there, some building in a cluster, it will be showing. So the ability, if you are having a very high spatial resolution, we will be able to identify the object on our Earth surface clearly. So that will differ from one sensor to the other. Second thing, what it is asked about is spectral resolution. In spectral resolution, we are not identifying the object based on their dimension. We are differentiating the object based on their spectral response. That means I have shown you in the slide I have shown you. For vegetation, its spectral response will be mentioned in a particular wavelength region. Whereas another object on our Earth surface, iron oxide, it will be there, or iron, any other rock will be there. Their spectral response will be there in a represented, their reflectance will be represented in a different wavelength region. So there we are trying to understand about the spectral responses of an object. So the sensors, some of the sensors, they will be designed only in the visible range of spectra. Only that much of spectral responses they will be able to measure. Some of the spectra, they will be having the near infrared range of wavelength it will be representing. So as some of the object on our Earth surface which have a reflectance in near infrared region or further longer shorter wave infrared region and all, those responses we will be able to record. So these are the very basic differences which we can say with the spatial resolution and spectral resolution. So for our objective, based on our objective, we will be able to we can say we are able to decide which satellite imagery we want to use. So I hope the participant got clarity in this one. In that slide, I will show you one thing. I think I won't take much time. So you can see here, this is a ground. There are many things are there. You can see different colors. So that different colors which you may be seeing of different rock type. So that is possible only when a data which is having a bands in our spectral wavelength region from a visible to short wave infrared, because the rock types which we are having there, they may have a spectral responses in longer wavelength also. So that we will be able to see. Okay, so that is the different differences we can see. So here the spectral response of a vegetation you can see. That will be different from a water body. Its spectral response is this. Soil, it will be different. So all these things will be varying, that we will be able to understand from a imagery. Okay. So I hope it is clear.
Sir, some small information on it, sir.
Let me mute.
Hello. Sir, remote sensing applications in mining, geology, mineral exploration aspects, all aspects, but in defense purpose, recently is going in Russia and Ukraine, but they are using which technology in remote sensing, active sensors or passive sensors, based on the wavelength or frequency. They clearly target the ambush. Recently, Abhinav Bindra, particularly which sensors in remote sensing they are using in the defense.
Okay. Okay. So in defense purpose nowadays, see they are defense. They are having their own satellites. There are certain satellites which are not open to the public. There are many defense satellites are there. For the in India or every country, they will be having different satellites of very high resolution data they will be getting, and those data are not at all available for our public people. Even our DRDO and ISRO, they are combinedly working on, and they have launched so many radar satellites are there. That means our active remote sensing satellite, which can operate in the night time also. There is one Hindi movie which called Uri. In that they are showing something like a drone which are developed by the DRDO. They have kept a sensor in that one. That is a shortwave infrared sensor. Something they have kept in that one, and radar sensor also they have kept in that one. So they could take the imageries in the night as well. They could detect the features from that one. So that radar technology is widely used in the defense purpose. Not only now in this war, a few months back in other Palestine and all those issues also, they were targeting the missiles using this radar techniques and all. And there are certain things which will escape from that also. They are unable to target their missiles in that cases. So very advanced, which is not at all open for the public people, for us civilians. There are many technologies based on this active and passive remote sensing they are using. They are both the things combinedly they are using in the war front.
Okay, sir. Thank you.
There is one question in the chat box, sir. Relation between photogrammetry Rs and GIS. See, as we were discussing as the evolution of our remote sensing, we were telling photogrammetry earlier we used the aerial photographs. So there we use the spectroradiometer. Our what we can say aerial photographs. We used to stereoscopes. We used to visualize the aerial photos. Okay, then from that digital photogrammetry it has come by wearing the 3D glasses, using the digital softwares. We used to analyze the photos, aerial photos. So that comes under our photogrammetry. In remote sensing, it is a part of remote sensing. That is a one part, we can say, a technique which has been used. In satellite remote sensing, further satellite imageries are used. And GIS, in generally, we are telling that it is the geographical information system, which involves map making, which involves vector analysis, raster analysis, all the things. That is just like giving a geospatial tag for our work, what we are carrying out. So all these three are a part, means we can say it is all working together. We can say different branches in different time period, they got importances and all were there. So all are trying to understand about the Earth's surface studies. Okay.
Another question is rising in chat box.
By this GIS, can we estimate the location of hydrocarbon? Yeah, we can see. First of all, we need a ground study. We need a ground information, or using the remote sensing, we will be creating different layers like alteration layers, structural information that we can identify for a particular area. Okay, based on the lithology of that area, hydrocarbon, whether that area is favorable for hydrocarbons and all. Then lineament is an important thing. Structural information we can demarcate or we can identify using the remote sensing satellite imageries and all. Then after that, we have to integrate those things in a GIS platform. From that, we will be identifying a probable locations for locating the hydrocarbon. So the final stage of integration, that will be done using the GIS technique. Okay. So this one I had carried out earlier, way back in 2009-10. We had done, when I was in a private firm, we did the same kind of a work for our Reliance for the hydrocarbon explorations in Peru and Yemen countries. So it can be done. So the LIDAR and LIDAR technique we are using, it's a part of, again, active remote sensing sensors we are using. So based on the wavelength, spectral wavelength which are used, see, as we have discussed the electromagnetic spectral wavelength, different ranges of wavelength are utilized for LIDAR as well as laser radar techniques. So the main difference will come in that aspect. Okay. In LIDAR, we will be using a specific wavelength region for the data acquisition. In laser radar, we are using the another wavelength region of electromagnetic spectra, longer wavelength region. We are using in the electromagnetic spectra for attaining the information. So in LIDAR technique, it will be more specific. You can go for the elevation informations and all. We can identify in a better way. Okay. What is the main difference? Seismic survey and GIS. See, seismic survey, I can connect that with a geophysics aspect, we can say. So the ground penetration, we are doing GPR studies, we are doing seismic surveys, different seismic surveys we are carrying out. So that will give the beneath the surface informations. Okay, in GIS or remote sensing, especially we are taking the superficial informations we are taking. Okay, so that is the basic thing we can say. We have so many advantages of remote sensing. What are the disadvantages of remote sensing? See, if you say the disadvantages means, always when we do a remote sensing study, depending upon the studies, we should always go for a ground check. Okay, sometimes what we used to see in that, people will tell, yeah, from this I could identify this one. This is true. Unless until we do a ground check or a detailed study on the ground, we cannot finalize those things. That is one thing. Another disadvantage in that, see, as you have seen, different sensors are there. My intention is to map an area, all the information I require. but sometimes the freely available data may not be available. Okay, so the sensor, their technicalities, their differences, their technicalities will be varying for different remote sensing techniques. Okay, so that is a disadvantage, we can say. Mostly we are taking as an application as an advantages of remote sensing. Okay, cracking Gsi exam. Okay, suggestion is that first of all you have to follow the current syllabus. Okay, whatever the exams, competitive exams which we are planning, you should first follow the syllabus of that exam, Gsi exam. Currently, for the last 1 or 2 years, the changes in the syllabuses are there. Try to follow that syllabus. So it is having a general paper you are having, then you are having a detailed papers also you are having. So preparation for a general paper and the first paper and the detailed paper, it has to be given weightage. Okay, so general studies also you have to take care. Geology aspect also you have to take care. So once you are preparing, you can prepare the notes. You can prepare the different notes and you can utilize that for the exam preparations. And if you are planning for cracking the exam for the next year, I am especially talking to the MSc second year students. They will be eligible for cracking when they are doing the second year, right? So you can
Other messages, no, sir.
You can start preparing along with the.
Sir, next section will start, sir. The time is.
Sure.
Doesn't have time.
Okay, yes, so sir. That is the thing. Okay.
Thank you very much, sir, for interaction of basics of remote sensing and its applications in geosciences. Sir explained excellent about spectral resolutions, sensors, and the GPS, orbit of satellites, and etc. So these are very important fundamental basics to the students. So thank you very much, sir, for explaining these things. Thank you, sir.
So
the next section.
All of you, thank you very much for listening, and thanks to the organizers also. So I am leaving the meeting now. Thank you very much.
Thank you, sir. The next section address the question.
Good afternoon, everyone. Good afternoon, Varna. It gives immense pleasure to introduce our research colleague and junior and my best friend Mallesh. He's becoming a doctor, Dr. Mallesh. Okay. Both of you same guide our Professor M. Narasimha Reddy. Sir. Okay. Dr. Mallesh Ganji, senior geologist in senior geologist GSI Training Institute. Okay, he is from Usmania University, batch 2008. He is a university topper. After completion of MSc, he joined in UPSC Geologist. Is cracked in 2000 after 2010 to 11 UPSC Geologist examination. Okay, he joined as a geologist. After that, he became a senior geologist in GSI. He is also teaching faculty in Usmania University as academic consultant and assistant professor 3 academic years. He is also meanwhile when the teaching and student level is attended a dissertation work in the study on unconformity types of uranium mineralization in Lambapur Pedagatu in Nalgonda district in Andhra Pradesh. So his PhD title is Petrological and Geochemical Studies of Anorthosites and Rocks and their Tectonic Settings in Khammam System Belt. His study area research is shortly submitting. Then he is involved in a number of projects with collaboration with the GSI. in assessment of iron ore resource in Gottugudem, Kondipalli block and Bhadradri, Kottagudem district of Telangana, and also iron ore mineralization and map of the possible northwestern extension of Karimnagar grunlite belt of around Kottapet, and specialized in thematic mapping in Sarkala, Elambelu, Sarpaka, Bhadrachalam area nearby is thematic mapping is done, and he is an perfect and geochemical mapping in various in India, like Tamil Nadu, Nellore district, and geochemical mapping in Raipur district in Chhattisgarh, and geochemical mapping in Maharashtra and Adilabad in AP in previous years, and geochemical mapping in Chandur district of Maharashtra, and geochemical mapping in Maharashtra is excellent work done in geochemical mapping. Okay, his publications in different international national publications. Okay, he is involved in so many number of programs, refresher programs, orientation programs like refresher for EPA, EPMA, and United Nations classification, UNFC classifications, Mines and Mineral Regulation Acts, and is promotional as a senior geologist in 2016 in GSI. And he attended number of programs, refresher course, geological mapping. He is also involved in administration, finance, vigilance as a scientist, and he is also geochemical data processing, is an expert in the interpretation of data and exploration of geochemical energy. And he also attended 35th and 36th geochemical orientation programs as well as seminars in submitting the paper. Very grateful, I think. Thank you, sir. Thank you very much for this giving this opportunity. My colleague Jim Malesh. Thank you.
Okay, thank you, Dr. Machandar sir. Thank you for introducing me to the audience. Yeah, good afternoon, all of you. I won't take much time because the session is already late by 30 minutes. So I will finish as early as possible. And in your first session, you have learned about the remote sensing techniques, how to grab the data. Can you mute, sir?
Yes, sir.
So how to grab the geological data from remote sensing. Then now we are going directly into the field. So we have to collect the data from remote sensing, but we have to check in the field itself. And mapping is the main important part of a geologist's work. And remote sensing and ArcGIS and photogrammetry, these are all the tools which will be very, very helpful for a geologist. But ultimately we have to do mapping, and we have to explore the deposits by physically touching the objects, physically touching the rocks only. I will share my presentation. Are you able to see my presentation?
Yes, sir. We can able to see your presentation.
Yes, sir.
Yes, sir. You can go to the presentation.
Yeah. So the topic is introduction to the field geology. It's not moving. 1 second. Yeah. The topic of presentation is introduction to the field geology. So we have to have weapons to go into the field. Our weapons, as a geologist, we have weapons in the form of Brenton compass, hammer, pocket lens, next topo sheet, and GPS. Okay, then haversack and camera and tape and Brenton compass, then diagonal scale, then cap, and ultimately we should have a diary also to note all the field data. Then this is also the photographs of the different field equipments. Earlier we used to have a clinometer. We used to take the geological data in the form of through clinometer, but now we have advanced Brenton compass. Then Brenton compass is very important instrument for a geologist, like gun for a police. Police wears gun to the belt, and as a geologist we wear the Brenton to the belt, because without Brenton we cannot collect any data from the field. We are going to the field to collect the geological information. So for collecting geological information, Brenton is must and should thing. This is a clear picture of a Brenton, where it can holds by a leather pouch. Then now I am coming to the different parts of the Brenton. Okay, if you see this Brenton, we have a vertical plane, that is long side. This is a side plate, and here this is the peep side, that is small side, and this is the long side. The use of these sides are when we are taking our reading, our bearing, our front or back bearing, we should see through this sight only. Okay, from this side we have to see any object, and through reflection in this mirror we have to correlate the the identical place. For example, we are taking bearing of any hilltop, or we are taking bearing of any monument. So we have to keep our Brenton in this side, where mirror should be our side, and this side should be from opposite side, and we have to see the landmark through this side. The peak of the landmark, for example, peak of a hill will be should be positioned here, and the entire vertical plane should be positioned in this long side. Okay, then here there are another different parts. For example, here we have a measurement tape. Okay, here this is called a here it is called long level and or azimuthal level. Here we have 0 to 360 degree readings. From here it is 0, and here it is 90, 180, 270 and 360. Here we have the entire 360 degree reading, and here we have two round bubbles. One is round and one is the rectangular in shape. Here this round level is used for measuring the strike, and here the rectangular bubble is useful to measure the angle of the dip. Okay, then we have another two readings in this the major thing, means inside the major thing. This one is having 180 degrees. Are you observing here? Here this is the 380 degrees rotator, and here it is only 180. So here it is 0 to 90, and here 0 to 90. This 90 will give data about the other side, and this 90 will give data about the other side. And here inside of this there is another small meter. Here it is not visible, but I will tell you. Here we have 0 to 100 and 0 to 100. Okay, here this is 360, and here 0 to 90 and 0 to 90. But here we have 0 to 100 and 0 to 100, and from 0 this 100 is up to 45 degree level. Are you observing? Here the 0 from 100 is 45 only, and this third one, which will be useful for calculating the slope of the hill. Especially in engineering geologists, they are using this third one, because they have to calculate the slope of the hill. So that's why this third one is very useful for engineering geologists. Okay, then the next one is sighting mirror. This is a plane mirror where we can see the long sight and peep sight here in this, and this is the windowing mirror. Okay, you can adjust this through this help of window. You can adjust the sight of the location. Then here you can observe one more small white colored bubble. Okay, this bubble is known as magnetic needle, where this dial, north and south dial, is to rotate always based on that direction. But when you want to lock this direction, then you have to press this magnetic needle. Then only it will be stops. So this is the front side of the Brenton. Okay, here it is very clear. This reading of 0 to 360, this is 0, and here 350, and this is 360 also. And here you can observe at 90 we have 0 reading, and this will go on to 90 when it meets 0, and here also from 90 to 180 it is also another 90. So this 0 to 180 we have 190, and this is the other side of 90. And here you can observe the third one where we have 100, 0 to 100 and 0 to 100. This 0 to 100 will reflect up to 45 degrees only. Okay, why we have 45 degrees here? Are you observing?
Yes, sir.
Are you observing the screen? So why we have this 45 degree? Because the slope is always less than or more than 45 only, isn't it?
Yes.
Yes, that's right. And going for next slide. Here this is the back side of the Brenton, where we have what is that? This magnetic needles. So this is adjustable needle where you can adjust magnetism. For example, if you are going to any area, there is always a magnetic what is that inclination. So to correct the magnetic inclination, we have some black color bubble. It is like a screwdriver. You can move this screw according to your magnetic inclination. And here we have this vernier adjustment. With this adjustment only we can calculate the dip amount. Okay. When this is for dip amount, this will be rotated for calculating the dip, and this will be rotated through this instrument only. This is called Vernier adjustment. Okay, and this what is that? Adelaide mount and ball socket mount, this tripod mounts. These two parts will be useful for doing survey work. When we are doing a survey in a larger scale, then we will use to mount this Brenton compass to that Adelaide mount. Then this is the way to hold the Brenton. Okay, always this mirror should be towards you, and this sight, this long sight should be opposite to the you. And there are two types of taking of reading. One is quadrant reading and another one is azimuth reading. For example, you are observing a rock formation which is having 40 degrees. So you can call it as a 040, or you can call it as a north 40 degrees to east. Okay, this quadrant bearing will be only from 0 to 90 from north to east, or 0 to 90 from north to west. Okay, but this azimuth reading will be always from 0 to 360. Okay, are you clear? Anybody have doubts? You can interrupt me during the lecture session and you can ask. Okay, because this, one second. Yes, we have 0 to 360 degree reading here. Okay, if we calculate any strike amount of any particular bed, you can tell it as a north 60 degrees east, or you can tell it as simply 060. Otherwise, you tell it as a 310, or you can tell it as a 050. Okay, why 050? Because it is lying 50 to the west. This is the north. Okay, from here, if you are counting 60 degrees, that is north 60 degrees east, because east is this side 90 degrees. And if you are getting a reading of 300, for example, so what you will tell, this is a reading of 300, otherwise this is 60 degrees from west side. Okay, this is the west side now, 270 degrees. That's why you have to tell 60 degrees from north to west. Then after knowing the different instruments which are useful to map in the field. First, what is map? What is map and what is geological map? Map is a two-dimensional diagrammatic representation where you can record surface features, and maps can be many number of times. For example, there are political maps, climatic maps, road maps, resource maps, and topographical maps. And based on the scale of the mapping, we have larger scale of having 1:12,500 and a smaller scale having 1:50,000. Where our normal topo sheets are having a scale of 1:50,000, where you can observe only major road lines or major ponds or major towns or small towns also. But if you take a map of 1:12,500, you will observe each and every individual rock formations also. Means the morphology, the shape of the individual rock type also you can observe in a larger scale maps. For example, we have a map of India, and every map, every topo sheet having some record. For example, 53p/4. So what it indicates? These are all the index of international series of base maps, where India having 43 to 52, then 39 to 71, 48 to 72, 41 to 73, 47 to 65, 43 to 66, and 49 to 67. These are the different quadrangles covered by Indian subcontinent, and within that also we have number of topo sheets. Every, for example, this is 53 degree sheet. Here we have from A to P, there are 16 degree sheets. Under 53 we have 16 degree sheets, and each and every degree sheet also divided by one topo sheet, that is B. For example, 53 B/3. So in under B also, B quadrangle also, we have 16 number of topo sheets. So main unit, then 16 degree sheets, and under one single degree sheet we have 16 topo sheets. For example, Nalgonda is covered by 56 P/3. Topo sheet number 56 P/3. So each and every area is covered by different topo sheets, and India having topo sheets of having more than 20 topo sheets, more than 20 reading sheets. Okay. For example, this is a topo sheet 57 B/8. Okay, it is belongs to Chitradurga, Karnataka. Okay, in every topo sheet you can observe n number of features, n number of morphological features within that topo sheets. Some reflects the roads, and some reflects the barren lands, some reflects the villages. So there are number of features you can observe in topo sheets, and with these features you have to identify geology also for preparing geological map. For example, here it is a part of topo sheet. Here you observed one hillock. Okay, the hillock having a height of 976 triangular point. Okay, here you have to map. Here in topo sheet we don't have any lithological features. We have to find the rock types in the field, and we have to fill up with the colors different rock types. So for this you have to do the mapping. We have to do the mapping in the field. So what is that called? Geological mapping. We have to do geological mapping. So what is geological map? What is map and what is geological map? Map is a representation of two-dimensional picture where three-dimensional rock types are different features are there. That will be represented by a map. For example, a topo sheet. But what is geological map? Geological map is a map where it is consisting of different litho units, and not only litho units, we have different structural details also. So all these lithological structural data will be put on a map, that is called a geological map. Okay, then why we are doing geological mapping? Why there is a need of geological mapping? Because we have to do mapping to explore the mineral deposits, to explore the different type of rocks available on the surface or subsurface of the earth, and we have number of unconsolidated earth materials and different landforms. So these all geological features we have to map through geological map only, and after completing the mapping only you can identify different type of mineral deposits in different type of rocks. So the mapping is very important for basic scientific and academic purposes and for public good geoscience requirements also. So then we are going for next presentation. There are different type of geological maps. One is synoptic maps, the another one is basic maps, and the detailed one is detailed maps. There are three main important geological maps are there based on their scale. Okay, these synoptic maps will be very much useful for what is that called state or district resource maps, and the main important mapping is on topo sheets, that is called basic maps, which is on 1:50,000 or 1:25,000 scale. The third most important thing is maps used for mineral exploration. The ultimate goal of mapping is to explore the mineral deposits. So we have to map on a larger scale, that is on 1:1000 or 1:12,500 scale. So that is called mineral exploration related maps. And these all the maps will be mainly plotted on topo sheets which are printed and available from Survey of India. We use as a base map and we can prepare a geology on that. Then before going to how to do mapping in the field and how to do recording in the field and how to do plotting on a map, we should have some basic requirements, because before going to the field we have perfect planning. When we have to go field and how many number of traverses we have to take and what data we are going to collect. If we are collecting only samples for chemical analysis, we have to plan in such a way. And if you want to do mapping, not for selection, not for sampling, then we have to plan. We have to plan properly before going to the field. Okay, this is the first class where it will be introduction to the field geology, and the second lecture will be mainly on how to do mapping and what are the fundamentals of the mapping. Just 1 second, I will share the presentation. Fundamentals of mapping. Yeah, this is the main important thing for academic people. Are you seeing my presentation?
Yes, sir.
Okay. Okay. At any time you can disturb me, no problem. Then fundamentals of geological mapping. While carrying out geological mapping, we should ask ourselves three main important questions. What are they? Where I am in. Okay, when you are in the field, first you have to locate yourself, where I am and how much distance from nearby village. So first we have to locate ourselves in a field. Then what is the second question? What do I see? So what are I am observing? What are the different rock formations or what are the different geomorphological features I am observing? The third one, what does it mean? Means, for example, you are observing any younger formations of sandstone or limestone, or if you are observing the oldest rocks on the surface, for example, granites or the basalt rocks. So what it means, what it indicates. So first we have to locate yourself, then you have to observe the lithological features, and thirdly you have to think what are the reason behind this. Because in our geological map of India, we have granitic rock types in the southern part and basalt Deccan Traps rocks in the western part. Okay, and alluvium and sandstone are different rock types in the northern part or northeastern parts. So why so? Why they have formed like that? There is any other reason? So we should think on a global to regional prospect. Then you have to think about the local prospect also, because India is attached with the Australia before 560 million years ago. Now it has moved to the Eurasia plate. It has collided with the Eurasia plate. Then Himalayas have been formed. That's why you observe more youngest rock types like sandstones and limestones in the northern part, and the oldest rocks which are available on the southern side and western side of the India, like granites and Deccan rocks, which are also available in the Australia. So on a global scale, on a regional scales, you have to think before going to the field. So where I am, what I do see, and what does it mean in detail. For example, if you are seeing any person's face, what you can observe? 2 eyes, 1 nose, and 1 mouth. So you have to note down 1, 2, 3, 4, 5, 6, the different features you observed on your opposite persons. Like that, you have to note down all the geological features also. So here the first question, where I am, the location, what spot on map. So if you are mapping on a topo sheet, so in which part of the topo sheet you are, and distances and directions, what are the different roads, and what is the different directions you are moving for mapping. Then altitude means height. Then what is the tectonic domain? It is a Eastern Ghat belt or Western Ghats or Southern granite terrains, and which type of area. Just now I told whether it is igneous terrain or sedimentary terrain or metamorphic terrain. Then you think about the geological time also. Then what do I see? You can see the lithology, you can see the contacts between different lithological formations or groups, and you can observe different structural features, geomorphological features, and you can observe minerals and fossils also. Sometimes you may observe only soil, because if an area is having highly weathered portion, you can observe only simply soils only. You cannot observe any rock types on the surface. So then what does it mean? So for example, you are observed a granite. So you should think about the petrogenesis and the tectonism, why granites have been observing this place, why not in the northern part. So you should think on what you are observing. Then the first important thing is you have to locate yourself in the field. So what you will do? Anybody? Nowadays we are having GPS. Through GPS you can see the latitude and longitudes. Then you will write and you will put the location on a topo sheet. But what is the basic what is the base concept? Without using without using GPS, how you can locate yourself in the field? Anybody? Yeah, landmarks. So observing the landmarks on the topo sheet, like hills, isn't it? So if you are on hilltop, then it's okay. But if you are on the valley, how you can locate yourself? Yes. I will show you the next slide. For example, here it is a topo sheet representing Chitradurga town. Okay, you are somewhere here. So what you will do? You will take reading from one hilltop. Okay, then you will take reading from another hilltop. Okay, then you will take reading from another hilltop. Okay, then you will put a dot where it indicates the location of yourself. Okay, have you understand? Here at one place you are standing, you are taking reading from one hilltop by using front bearing. Just now I told you how to take a front bearing. Just you have to hold a Brenton where mirror is siding yourself and the peep side should be siding to the object. Then you will take a reading that it may be reading of north 40 east or 040 or 300. Just you put a line, straight line like this. Then you will take another reading from another hilltop and put it a line, just a straight line from that place. Means whatever the reading comes, for example 300, just draw a line with scale just 300 line. Then you are taking reading from 90, just to draw a line. Then you are taking reading from 20. Are you understanding? For example, here this is the north, this is the north. Then you are taking from this hill, that is around 20 to 30 degree reading. Then here it is almost east to 90 to 95, and here it is northwest, means that is 320 or 330. Then you draw a 3 single lines, then coincide these 3 single lines will give you a dot, that is your location. Okay, here it is the location of this geologist from 3 tops, hill tops. Anybody? All of you understand the concept behind locating yourself in the field? If anybody have doubt, just ask me, then I will repeat once again. You simply, what you have to do, you have to take the reading of 3 locations by using your Brenton. If you are taking reading from left side, it may be around 300 reading in your Brenton compass. If you are taking reading from another hill which is locating east of you, that may be 90 degrees. And if you are taking one more reading, that is northeast side, that is 20 or 30 reading. Then on topo sheet, just you draw a 3 lines, and where it will coincide, that will be your location. That will be your location where you have stands. Okay, then next, this is Brenton, this is diagonal scale. With the help of diagonal scale, you can easily mark your location on the topo sheet. Earlier we used to use scale and what is that conical scale. Okay, and we are starting geological mapping. For example, this is a house where this indicates the strike, which is horizontality of a horizontal line. Then it is indicates the dip direction. Okay, this is a 3D phase where this represents the strike horizontal plane, and this is 90 degrees to the strike. Okay, then it is dip direction, and this is the amount of the dip or dip angle, where if you put a water on here top of the hill, the water will flow like this only. This is the dip direction, this is the dip amount, and this is the direction, dip direction. Then it is also a schematic diagram where it shows strike and dip and the amount of dip. And can you anybody tell what is the strike here in this photograph? Anybody?
North-south.
North-south.
No, I'm not asking the direction. Which is the strike? Here, for example, there are number of planes are there. Is this the strike or this? Which one is the strike? Yeah, I am showing 2 planes. One plane is this, one plane is this. Which one is the strike of the particular rock formation? Yeah, obviously this is the strike of the rock formation, because this rock is trending towards this direction. Okay, here you can observe different layers of the rock, where this rock is trending in this direction and dipping in this direction. Okay, this is the dip of the rock. And for calculating any strike or dip of a rock, you should observe at least 2 planes. Means you are observing this one plane, and you should observe this second plane also. Okay, this behind there is another plane. This plane also you have to observe. Then only you will.
మీరు కర్సర్ పెట్టి చూపించేది కనిపించట్లేదు సార్ అక్కడ.
Oh, okay. Yeah. Now, okay na? ఇప్పుడు okay na?
Okay, sir.
Yeah. So this is the plane where strike it resembles the strike, and here this is the dip. Okay, and you have to observe at least 2 planes for calculating any strike or dip of any rock, because if this strike may be down this side or down this side, so how you can calculate the dip? You have to observe at least two planes, then only you will calculate the dip of the rock body. For example, here there is one line, okay, this line. Can you tell me on which side this line is dipping? This side only. Why? How you can tell? Because here I have observed the rock is dipping this side. I have observed the two planes. But if in any area this kind of rock formations will not be observable, then you have to observe the side of this plane, second side of the plane. Then only you will identify the exact direction of the dip and strike. And here the students are measuring strike and depth without having surface features, isn't it? In the previous slide you observed the rock, but here you did not observe any rock formation. So how you can take reading? Anybody? This is wrong or right? Yeah, obviously it is wrong, because without observing a single plane they are taking a reading. I told that we have to observe at least two planes, then only you have to take the reading. But these people, they are doing mistakenly taking the reading, because they have observed some rock pieces which are broken pieces. They see the pieces are aligned in a one direction, that's why they are taking the strike and dip. But it is completely wrong. And this is a schematic diagram where it represents time from 850 million years to 255 million years. Just it is a schematic diagram where rock formations have been deposited as a sedimentary rock, then it will got folding in one phase, then having intruded by different intrusive rocks, maybe dolerite dikes, then it has going on erosion, then again deposition, then again second stage of folding, then again third stage of folding. Are you observing the simple plane and after attaining different type of foldings? Folding one, this, folding one, this and this, and third phase of folding. So nowadays in metamorphic terrain where you are doing mapping, you can observe more than 3 phases of folding, 3 phases of deformation. So that's why you should be very keen to observe the different stage of different materials which are aligned in different directions. I will show the examples. For example, it is a simple hill, maybe call it as a Nalgonda hill. Okay, are you observing any features in this hill, students?
Yes.
Which feature you have observed? Yeah, Naveen, tell me what feature you have observed. I'm asking about geological features only, not roads or lines, not roads or railway lines. Yeah, these things. What are the different geological features you have observed? Okay, I will tell you. I will show you the next slide. Here I marked different lines. I will show you again the lines, previous slide. Are you observing the different lines? Anybody?
Yes, sir.
Yeah, you are observing different lines here. And here you are you observing any another different lines? Yes, here this is a fold and here it is a plane parallel bedding. Here it is parallel bedding. Here the bedding is folded. So you have to observe keenly. Means first you have to locate yourself in the field. Then the next minute you should observe the different features. It may be strike or dip or bedding, parallel bedding, cross bedding or folding. Just you observe. Then afterwards only you take the reading. Here, are you observing any geological features? There are Have you observing this? At alternate beds, there are light colored mafic minerals, sorry, dark colored mafic rocks. 1, 2, and 3. These are the intrusive igneous rocks, maybe dolerites, and the in between white colored rock is granites. Okay, so you have to take the reading of these dolerites. Then here different folding. You can observe the folding phase, and here you can observe cleavage planes. Yeah. Here this is the bedding plane, and between two bedding planes there is cleavage lines. There are number of lines are there. These small lines, cross-cutting lines are the cleavage planes. Okay, it is the bedding. Then these are the cleavage planes, and within bedding also you can observe the cleavage planes. Then here, can anybody tell what is the bedding and what is the cleavage plane? Anjanelu, can I take to some time, 10 to 15 minutes time?
Continue, sir.
Okay.
You can continue, sir.
Anybody, student? Are you observing any lithological differences? Color differences?
Yes, sir.
Yes, sir. Mafic and felsic color.
Yeah. This is the one type of material, and this is the another type of material. So here it is a one layer of the rock, and here different phase of the rock. So here you can also observe two phases of cleavages. This is the first phase of cleavaging, and here it is a second phase of cleavages. So you can observe different type of cleavages when you map starting from lithological differences and different cleavage planes and different number of intersecting cleavage planes. Here it is very simple. Alternate layers are there. Okay. Here alternate layer is mafic and some more little felsic layers, and in both layers you can observe the cleavage. Sorry, in this plane only you can observe the cleavage. Okay, this is also one more example, and this is very important example how you can observe folds in the field. Okay, you take this first diagram. Here it is showing some fold hinge. Okay, this is the plunge of the fold, and this is the left limb and this is the right limb of the fold. Just this is the left limb and this is the right limb, and this is the plunge of the fold. And it is here in the downside, one more folding phase is exposed. Okay, here also the fold is like this, and here different cleavage planes are there. This is also, if you observe in a field, you can observe more number of lines and more number of folding things, but you have to interpret which one is the first major folding and which are the different cleavages associated with the main fold. And till now you have been observed different features in the field and how to observe strike, dip, and folding and cleavages. So then what is the next? You have to plot that data on a map. Okay, whatever you observed in the field, you have to honestly write on your field diary whatever the data, strike, dip, folding, all the data, and you have to put on a map. Then only the map will be prepared. And here you observed n number of readings. Then you have to join these readings and make it as a fold or fault or a parallel bedding rock formation. Then this is a topo sheet where different contours are there, and you have observed some thin band of limestone. Then you have to draw like this, and you have to draw the strike and dip data also. Then next you have observed limestone and some other rock formation. Just you have to draw the faces of the morphology of the rock formation. Then here you observed different rock formations, and you drawn all the rock formations according to your data, geological data observed, means you drawn from the field, and you can draw fold synform and fold antiform also based on your structural data. Then you have to prepare a cross section by using different faces of the rock. For example, different faults and parallel beddings are there. You have to take each and every lithological unit data and you have to put it on a cross section. Like this is a cross section where it represents this blue color line of a geological map. Here you can observe different rock formations of gneiss, granites to sedimentary formations. And the cross section is a section where you can observe the thickness of each and every layer and the depth. What is the depth of that layer? For example, granites are always on the downside of the downside part, and the sedimentary rocks, maybe sandstone or limestones, always on the top of the map, top of the cross section. Then, for example, I have prepared a map in Bhadradri Kottagudem district, Bhadrachalam area. This is a map of Bhadrachalam area where Bhadrachalam is located and located here. This thick pink color represents the Khammam schist group of rocks, and this light pink color represents the what is that called, Bastar group of rocks, where Chhattisgarh has been started. Chhattisgarh group of rocks has been started, and it is the boundary between Eastern Dharwar Craton of Khammam schist belt and Bastar Craton of the central India. And this light orange color represents the Barakar formation, Kamti formation of the Gondwana, and this green color represents the Talchi formation of the Gondwana. And here you can observe green colored rock type. Okay, here this green colored rock type are the Mafic Rocks. These Mafic Rocks are responsible for formation of the base metal deposits in that particular area. And you can observe the different bluish color rocks, sky blue rocks. These are all calc silicates. And here this light sky blue color is Bhadrachalam hill, where this Bhadrachalam temple is there. That is occupied by the calc silicates. That's why calc silicate having a nature of easy weathering. That's why the hill is weathered and this much of portion only remains. Okay, and here this portion represents the Pakal group of rocks. Pakal group of rocks which is occupied by the hills. So that's why you have to take reading honestly in the field, and you have to observe different rock formations, and you have to record all the lithological data and structural data and contact between different lithologies. Then you have to put it on a map. Then map will represent like this, which represents different type of rocks of granites of the Khammam area and gneisses of the Bastar Craton Bhadrachalam area. So participants, students, anybody want any clarification or anybody wants any discussions, please ask. In chat box 56.
No questions. No questions in chat box, sir.
How many type of compasses? Actually, earlier we used to have clinometer. Okay, clinometer. The drawback of the clinometer is we cannot observe the slope through that clinometer, and we cannot observe the dip amount correctly. That's why during 90s, Brunton, the scientist, geologist name is Brunton, he has founded out the latest compass that can be called it as a Brunton compass. With that compass, we can take the data. That is the latest one, compass. Any students or faculty members also, if you have any queries, just you can ask.
Sir, good afternoon, sir. afternoon, sir.
Good afternoon.
Sir, can you explain head, dip, and heave?
What is it?
Head, dip, and heave. What is the difference between heave, dip, and head?
Of a of a fold.
Yes, sir. Can you draw a picture?
One second. This fold.
So only relation between head and dip.
Yeah, one second. The dip of, for example, this is a fold. Here it is plunge of the fold. Okay, you can measure the plunge direction and dip, and you can measure this axial plane direction and axial plane direction also. And here you have two limbs on which on other side of the fold you can observe the head. Hello?
Okay, sir. Okay. Thank you, sir.
Okay. Anybody?
Any questions from participants?
The main important thing you have to remember is you have to take the data honestly. Whether it is fault data or fold data or strike or dip of any rock formation, you have to take data honestly. Then only the map will be represents true data and map will be fruitful. How can we identify younger and older fold? Okay. For example, here we are observing a fold. Okay, here we are observing a fold. Okay, and here, if you observe, there is one more fold here. This is the major fold. You can call it as a F2 or F3 fold. Parallel to that, on either side of the limb, you can observe this fold is also folding. Again, it is folding. Okay, actually, this is the parallel layers. This is the quartzite layer, and this is the magnetite layer, where alternate layers represents the H0 plane, and this H0 plane is folding in this direction first. This is S1 fold, then this F1 fold again folded in this direction. This is F2 fold. So that's why this is the older fold, means F1 fold, and this is the younger fold. This is the F2 fold. Is it clear, Riyaj, MD Riyaj?
Yes, sir.
Just which is parallel to the main bedding, means the different lithology is there. When it is folded first, then that is called F1 fold, and when it is refolded, then it is F2 fold. Sometimes this F2 fold also again folded, that is F3 fold. Okay.
Okay, sir.
Yeah. Anybody?
Any questions from participants?
If anybody is hesitant to speak, just you can put it on chat box. No problem.
Okay, sir. Thank you. Now the section concluding and remarks give by the Venkatesh. Please give the concluding the webinar.
Good afternoon, all respected dignitaries and my dear Good afternoon, all. Thank you for being here today, webinar, and thank you, Dr. Anup VM, Senior Geologist, and Mallesh Ganji, Senior Geologist from GSI. And thank you from the bottom of my heart for taking time from your busy schedule to be the guest speakers at our webinar. And thank you very much, Anup VM and Mallesh Ganji Garu, for a wonderful presentation, and it will enlighten our knowledge for this presentation. And so the Anup VM explained the principles of remote sensing and its applications in the remote sensing techniques, and evolution of remote sensing, aerial photographs, and drone techniques used in remote sensing, and understanding features on Earth's surface by using remote sensing techniques. So and also has explained very well about sensors and platforms, and active sensors and passive sensors. And the MSc students and research scholars also, this presentation is very useful for the MSc students and the research scholars and academicians also. And coming to Mallesh Ganji sir, so his presentation was enlighten our knowledge in the field of geological mapping, and he explained about Brunton compass and the principles of geological mapping and locating ourselves in the field without using GPS with the help of this topo sheet and the Brunton compass. So the students and research scholars and academicians have got some basic knowledge through these presentations, and as explained about the strike and dip, and they showed some structural features from the field photographs, bedding and cleavage, and folds, plunging folds. So many have covered in the geological mapping presentation. And thank you, sir. Thank you, Mallesh Ganji Garu and Anup VM sir, for the presentations. And now I request Jisudhakar sir give a vote of thanks regarding this seminar.
సార్ మీరు మీట్లో ఉన్నారు.
What happened, sir? What happened?
Yeah, Jit Sudhakar sir's voice is not listening. Is not sound is not there. Maybe
Yeah,
some
yes, sir.
problem.
Anjaneyal
And
sir, please respond.
yeah.
Anjaneyal sir, please respond.
Yeah, before that, just I want to clear one doubt.
Yes, sir.
Here,
Sudhakar.
MD Riaz asked one question in chat box. There are several types of compasses. What is the main difference among those compasses? So mainly all compasses will work for similar use only, taking strike and dip. But this Brenton compass is made up of brass. Okay, brass and copper. That's why there is no magnetic inclination. So for accuracy, generally we used to use Brenton compass for accuracy. That is the main difference only. But with the compass, we cannot take the slope reading. With the Brenton, we can take slope reading, dip reading, strike reading, all the readings without any magnetic inclination. That is the main difference. Yeah, over to Sudhakar.
Yeah, thank you, sir. The distinguished guests, invited dignitaries, teaching staff, non-teaching staff, students, and my dear participants, once again, I extending a warm and very good afternoon to one and all. I feel immense pleasure to take this opportunity to propose vote of thanks. I, G. Sudhakar, on behalf of Department of Geology, University College of Science, Mahatma Gandhi University, and the entire fraternity of the institution, extend my sincere thanks to the Almighty for making today's event a grand success. I would like to thank our Honorable Chief Guest, Professor C.H. Gopal Reddy, Vice Chancellor of Mahatma Gandhi University, spared time from his busy schedule to grace the occasion. I would like to thank our guest of honor, Professor Krishna Rao T., Registrar of Mahatma Gandhi University, who today we had an opportunity to hear our thoughts, and this will surely encourage us in our future endeavors. I would like to thank our today's guest of speaker, Sri Anup VM, Senior Geologist, GSITA Hyderabad, for his active participation in this event. We have got a lot of information which will truly help us in our life, and we have no words to offer gratitude for your valuable presence. Our students and participants are very happy and so excited with your presentation, sir. And I would like to thank our another guest of speaker today, Sri Mallesh Ganji, Senior Geologist, GSITA Hyderabad. You truly made this day enlightening for us. Your deep and intellectual way of imparting knowledge has added to the glory of this event, sir. I also would like to thank our beloved chairman for this event, Dr. J. Upendra Reddy, Principal, University College of Science, Mahatma Gandhi University, for his wholehearted supporting for conducting this event. I extend hearty vote of thanks to our convener, Dr. M. Anjaneyulu, in charge head Department of Geology, University College of Science, Mahatma Gandhi University, and the staff members, Dr. K. Madhusudan Reddy, Dr. G. Machender, and Mr. B. Venkatesh. I want to appreciate their untired efforts for making the event in a fruitful way. I would like to thank, last but not least, my dear beloved young student friends and participants for making this webinar a grand success. Once again, I thank one and all present here. Now I'm going to signing out this webinar. Thank you once again. Thank you one and all.